All right, so in the enthalpy section 5.3, we're looking at example 5.8, check your learning. There are a couple of components here that you don't need to be familiar with, and I'll explain what they are, but this is a general problem that you'll need to be able to solve for the exam. So let's underline the pertinent pieces of information. One is that you have 1.34 grams of zinc. That is the starting material right here down in the reaction. What I usually do is I write down the amount of starting material or reactant that I have when I'm going through the problem. I write that under the balanced equation. And then it says it reacts with 60 milliliters of a 0.750. Big M means molar, M-O-L-A-R. Hydrochloric acid. So I'm going to write that underneath as well, right here. So I have 60 milliliters of a 0.750 molar solution. And it says 3.14 kilojoules of heat are produced. So when it says heat are produced, that tells you that delta H for that reaction is equal to 3.14 kilojoules. When it says produce, that means it's given off, so there's a negative right there. Okay, so moving on, determine the enthalpy change per mole of zinc. So the enthalpy change, what we're looking for, so the goal is to solve for delta H per mole of zinc. All right, so what we're going to do is we're going to take this information. These are the two quantities of starting material or of reactants that we have. And what you need to do is you need to convert that into the mole of the product. So I'm going to do that underneath in blue. And you need to do that for both zinc, 1.34 grams of zinc. And I also need to take my 60 milliliters of HCl. So on the exam, I'm actually only going to give you one reactant quantity, and from there, you'll then do the process of steps that I'm about to show you. So you won't have to deal with two different quantities, but I'm going to show you how to do both for the sake of this problem. So let's look at zinc right now. With zinc, I need to convert the grams into moles. So you use the molar mass given on the pure. And the molar mass of zinc is around 65.38. So change that on accident. 65.38 grams. Again, that's from the periodic table. Now I need to convert that into product. So I'm just going to focus on zinc chloride. It does not matter which product, in this case, you choose. Okay, so I'm just going to look at the product that just has 1 mole in front of it. Both of them have 1 mole, but I'm going to focus on zinc chloride. So there's 1 mole of zinc chloride for every, if you look at zinc, there's a 1 in front of zinc also. 1 mole of zinc. I'm going to equate that in just a second. And then I'm also going to look at my hydrochloric acid, HCl. First, I need to convert. Now, again, you don't need to be familiar with molarity. So if you don't want to look at this step, just skip it. But I am going to show those who are wondering about the answer in the book. I'm going to show you how it's possible to get that answer. Convert my milliliters to liters, and then I'm going to take my molarity, which is 0.750. Big M is the same as moles over liters. So notice that liters will cancel and milliliters will cancel, and you're going to be left with moles, in this case, of HCl. And then I'm going to take that and convert into moles of zinc chloride. Looking at the balanced equation, if I just scroll back up, notice that let me take this, there are 2 moles of hydrochloric acid for every 1 mole of zinc chloride. So 2 moles of each. So for zinc, I get 0.0200495 continues on moles of zinc chloride. And for HCl, let me scroll up. For HCl, I get 0.0225 moles of zinc chloride. Okay, so if you're wondering how you would do this problem, if I've given you two reactants, the answer is you need to calculate the moles of product, which I've done here. This is a product and this is a product. Notice this is a smaller number than this. So I am going to base what can theoretically be produced off of the smallest amount. Okay, this is called essentially a limiting reactant problem. However, for the exam, you are not responsible for being able to do this type of equation or type of problem when given two sets of reactants. I will only give you one. So in the case of the exam, I will give you a mass of a reactant. You'll have to convert it to moles using molar mass, and then you'll have to use the balanced equation to convert that to moles of product if I'm asking you for the moles of product. But let's go back up to the problem and see what it's asking for. So it says in this case that 3.14, I'm going to circle this, 3.14 kilojoules of heat are produced. So I want to know how much would be produced if I had 1 mole of zinc. So really the objective in this problem is to figure out how much heat is produced for 1 mole of zinc given the information of the heat produced for 1.34 grams of zinc. Okay, so let me scroll down and show you what you will be responsible for doing for the exam based on this problem. I'm going to take most of what's up above right here, this piece of the problem, and I'm going to write it down here. So 1.34 grams of zinc times 1 mole of zinc for every 65.38 grams is going to be equal to 0.02049, we'll just round it to a 6, moles of zinc. So that means the heat produced for this reaction is, we look back up top, 3.14 kilojoules, negative 3.14 kilojoules over 0.020496 moles of zinc. So if I want to know how many for 1 mole of zinc, I just need to divide that negative 3.14 kilojoules by the moles of zinc that I calculated. Negative 153 kilojoules per mole of zinc. And that would be your final answer. So again, the blue part, I'm walking you through what the example shows and how you would get to that final answer. The red part is information that is pertinent to the exam. So again, I will only give you one measurement for one of the reactants. You will then need to convert that into moles in order to calculate the final step, which is the heat produced, or the enthalpy. This is delta H per mole of, in this. Okay, let's look at example 5.10. So the question is, how much heat is produced by combustion of 125 grams of acetylene? So this really is just a stoichiometry problem. So what's given to you in table 5.2 is the amount of heat that's released per kilojoules of heat released per mole. So in the table, it gives you specific amounts of heat that are released for the combustion of particular substances. Now, if I look at acetylene, again, this is in table 5.2, gives me this value right here, and that's per mole. So essentially, I want to find out how many moles 125 grams is equivalent to. So I'm going to first write out my 125 grams of acetylene. I then need to convert that into moles of acetylene. 1 mole of acetylene, approximately 26 grams. Now I know that because if you look at the combustion reaction in table 5.2, acetylene is C2H2. So looking at the periodic table, if I add all of this together, I get a molar mass, which is given the symbol M, of around 26 grams per mole. So that's why I would know that information. So when I actually calculate this, 125 divided by 26, I get 4.807, and we'll just round this to 7. Just give at least 5 digits in order to not round too early. Okay, so I have about 4.8077 moles of acetylene. Now I'm going to use that measured value. Go down here in blue. I have 4.8077 moles of, I'll put C2H2 just to condense it a little. And I'm going to use the amount of heat that's given off. This is the enthalpy. I'm going to use that as a conversion factor. That just means I'm going to convert from moles into a different unit, in this case into kilojoules. So I'm going to put negative 1301.1 kilojoules for every 1 mole of C2H2. Notice moles of C2H2 will cancel. So I'm going to take my 4.8077 moles of acetylene, multiply it by the negative 1301.1. That gives me negative 6255.3 kilojoules approximately. And if you check your answer at the bottom of 5.10, this is essentially the same number. It's just given in scientific notation. So in scientific notation, negative, and it really should say negative on there. It has a positive number because the question is how much is produced, but it is more clear if you keep that negative right there. So there should be a negative there, and these would be your answers. These are equivalent. Okay, moving on to example 5.11. So this is yet another way to calculate delta H, again, which is enthalpy. And this is delta H of a reaction given what's called delta HF, or delta H of formation, the change in enthalpy or the heat given off in the formation of particular either compounds or elements. Now, what's given, the information that's given in this problem, if you read example 5.11 at the Check Your Learning section, it gives you the reaction, it tells you the reaction, and then at the very end it says the standard enthalpy of formation of hydrogen chloride gas is negative 92.3 kilojoules per mole. Now, there is an equation associated with this. If you are given delta HF values, in order to calculate delta H right here for the reaction, sometimes you'll see RXN for reaction. So to calculate delta H of a reaction given delta HF values, you need to take the change in enthalpy of the products minus the change in enthalpy of the reactants. So it's pretty simple, but you need to take all of the products and subtract all of the reactants. So what that means is I first look at the product. In this case, my product is HCl, and I'm also given the amount of heat that's given off per 1 mole of HCl. Okay, notice there are 2 hydrogen chlorides in this reaction, so I need to take this number and multiply it by 2, since there's a 2 in the balanced equation. Okay, so to get products, I'm going to take 2 times negative 92.3 kilojoules. Simple enough. Subtract from it my reactants. Now, there's a special little rule that you will not be responsible for memorizing, but I'm just going to tell you about this, that elements, these are both elements because they only consist of one type of atom. There's 2 hydrogens here and 2 chlorines here. They both have delta HF values of 0. So you're really just subtracting 0 right here. So your final answer then will be negative 184.6 kilojoules. I hope that's helpful. Let me know if you have any questions. These are 3 different ways to solve for delta H, or enthalpy, or heat given off in a reaction at constant pressure. You will be given any equation that is necessary to